Hello everyone. In this video, we will talk about buffering and rotor congestion control. First, let's think about the question, why do we need to do switch buffering? To gain time, to avoid packet loss, for switching, to reduce burstiness. The buffer also can use cut-through forwarding mode. A switch receives enough of the frame to classify it, inspect it to determine what to do next. If the output port is It can also use cut-through forwarding mode. A switch receives enough of the frame to classify it and inspects it to determine what to do next. If the output port is free, forwards it. Remaining bits will follow else, store it, and forward when the output port is free. However, there are some limitations of cut-through forwarding mode. It may have to store frame anyhow if the output port is busy. It's also difficult when the input rate is smaller than the output rate, and it's difficult when transmitting on multiple output ports. The store and forward mode receive whole frame before starting to forward it, and check integrity before forwarding. The cut-through method can start forwarding as soon as packet classified and the output port is free, and check the integrity while forwarding. When we choose memory devices, we want the device can have multiple ports, fast input and output port of frames, random access to same memory, and the multiple port memory we have buffer devices, and the video RAM. Static RAM and dynamic RAM are conventional single-port memories, but static RAM has faster access speed, but high power consumption and lower capacity than dynamic RAM. Video RAM could satisfy our requirement. It is multiple port memory, and it has large size and high speed, and the ports could access caches, and it achieves high shared memory, and the bit mask can show which bit to write in the row. First in, first out queues is the simplest type of buffer, and it could handle variable length packets, but the discard policy is limited, and it may also lead to head of line blocking. We may also consider about non-FIFO buffers, but it has to maintain a list showing packet service order with variable length packets. It's a trade-off between wasting space and having space scattered in useless positions, but it's easier for fixed length packets. When it comes to the discard strategies, we sometimes think about dropping old or new packets. We can also tag in packets that may be lost, and we also use partial packet discard strategy. Now let's move on to router participation in congestion control. We can do active queue management. Routers drop packets to notify the end of imminent congestion. The hope is that the early discard could cause sources to slow down before the buffer overflows. This assumes that the source slows down in response to packet loss. Routers can also do random early detection by discarding arriving packets with a probability that increases linearly with the average queue length. It seems doing explicit congestion notification is better because early packet discard is root. Routers could directly tell the source by sending a new packet to the source or set a field in a packet already going to the source. ECN uses 2 bits of TCP's reserved field to indicate. They are ECE and CWR. It may also use NS to deal with a selfish destination and router. That's all we have today. Thank you. Bye-bye.
Created using Powtoon.